So here we go. So good afternoon, and first of all, Lutz and I would like to welcome you all to our presentation, which is much about 3D, or something we call 3D solution templates, and what it's all about you will learn in the next couple of minutes. So before we jump into the details, first of all, we want to introduce ourselves. So my name is Christian, and I'm the team lead of Conterra's Spatial ETL product services team. And what we mainly do is, we sell FME, we build solution on top on FME, and we offer professional services around FME. And personally, I'm also a CityGML and FME enthusiast, and that's for a long time now. I think started working with CityGML FME back in 2007, and therefore it makes sense to be part of this presentation. And with that, I hand over to Lutz, who will give you a bit of background on what we actually do.
Yes, also a warm welcome from my side. I'm CEO of Virtual City Systems. We are a company located in Berlin, Germany, focusing on 3D solutions based on CityGML. We have a web-based visualization tool, and we try to bring more functionality into this web solution. And I'm enthusiastic about virtual mirror worlds. I really think that we need mirror worlds, digital mirror worlds, where we can do experiments which we can use for planning, which we can use for simulation before we do things in reality. I think it really makes sense. I have a planner background, so maybe that's also connected to that. I'm very happy that I can present with you, Christian. We were thinking about doing these templates since 2 years almost. And our joint story started actually even earlier, I think more or less since 2010. We had contact about how to handle CityGML data more and more often. And because there's growing uptake of CityGML in many European cities and also maybe in Singapore. And I also know that there are some examples in North America. So since CityGML is the main topic here for our 3D solution templates, I give you some background information about it. So what it is. First of all, it's an OGC standard. Well, we all know OGC standard. Then it's a pretty complex semantic data model for storing and exchanging 3D city models. And, you can also say it's pretty complicated. And I just picked one slide where I can pretty well explain the complexity of CityGML. So what we see is a building. And in CityGML, we now can decompose this building into its surfaces, which are wall, roof, and ground surfaces. And within a wall surface, you can also have windows or doors. And you store all these geometries and connect them with the semantics, so that you have a spatial semantic coherence in the model, which allows you, of course, then to really query your model. You can ask how many windows are in one wall surface or in the whole building. And these advanced queries that you can do, we think this is the power of CityGML. So this is really what makes the difference to pure 3D graphic models. And not even that you have this complexity on how to model this single building object, but it also can be represented in several levels of details. And the level of detail concept of CityGML, I think it's pretty famous by now. Everybody knows it, but it's still often misunderstood with computer graphics level of detail concept. So it's really a little bit different. Level of detail concept of CityGML really defines specific levels of detail where you say which feature classes, which semantics you apply to your object. And it's not just geometry reduction. And, as you have seen so far, there's buildings, but CityGML, of course, also covers other feature classes. So The top-level feature classes depicted in this image here is terrain model, land use, vegetation objects, city furniture, buildings, road, traffic areas, water bodies. There's also bridges, tunnels. So you can really represent all the topographic features of our cities and for our environment in CityGML. And well, there's a big problem with CityGML actually, especially in the early days. It was really that there was hardly any tool that could handle CityGML. There's no way to get it into the known CAD or GIS systems. And still, this is limited in many systems today. But then we have FME, and FME supports CityGML. I think you said 2007. Is that true? So really, really long time support for CityGML in FME, and of course, you know, it's because it's XML based, and I don't know, Don, is he here? Yes, he loves XML, so I think it was just a challenge for him. Yes, so FME and CityGML. Now it supports reading and writing CityGML data. It supports all these thematic modules with different feature classes in CityGML. It supports the level of detail concept, the attributes and properties of features, generic objects and attributes, and arbitrary ADEs. ADEs are application domain extensions you can use to add additional feature classes and properties to your CityGML model. And as long as you have in the schema files, which FME understands, you can handle any arbitrary ADE. If you really start working with it, you find that reading is pretty easy. Well, if there's a CityGML reader, you read it and you get your feature types, and then you can process them. So it's almost out of the box. There's some problems to it, but that's maybe something you can show later. So I don't go into detail here. Writing CityGML is not so straightforward. You really have to have an understanding about the CityGML data model, about the feature types, the feature classes, how to set the CityGML properties with FME, how to set your workflows up properly so that you really receive valid CityGML. Well, I think because of this, even with FME customers often find it very hard to work with CityGML data. It's still for many average FME users a big problem to process CityGML. And we have from so many projects that we did together or also separately as companies, rich fundus of workflows which we just think we should give to the community, which give you a first impression about how to set this up. It's like self-learning packages you can use and start up from there. And this is what we call the 3D solution templates. Well, basically it's FME Workspace templates and additional transformers that we provide. They are jointly developed by Terra and Virtual CitySYSTEMS. And we have 3 main topics that we focus on. So there are some templates for creating CityGML data, how to set up your feature types and route your properties. Then also reading CityGML and converting it into various 3D formats that you can write with FME. And then there's also a 3D City database reader. So that is the 3D City database is an open source database schema for storing CityGML on top of Oracle or PostGIS databases. And so we have created a reader that directly connects actually to these databases and get to extract the data from the 3D City database. So, and well, these templates pretty much all look a little bit like this. You have your source data, your output data. Well, it's Workspace. And when we put some description into these templates and what they do, what source data you need, what prerequisites you need, and then there's some annotations about what is done by certain transformers so that people really can start understanding the data flow and well, adapt them to their own needs. And yeah, we uploaded them just 3 days ago, I think, to FME Hub. So there's now 15 new workspace templates on FME Hub. And Christian will gonna show you some examples from the FME Hub and how to work with them.
So just before we jump into the demonstration, I would like to highlight that we also ship some sample data set with these solution templates. And this sample data set is coming from a German city. And you can see on the right-hand side of the picture what is in that data. And I would just call it a typical set of data that normally cities have if they want to provide, or if they want to do 3D city modeling, right? So these templates also include building footprints and attributes. Building level of details too are included, then a digital terrain model, autophotos and trees. So all these ingredients we make use of in our 3D solution templates. And then I just want to jump into the FME Hub. And as Lutz says, if you start searching for CityGML, you will see that there are a bunch of 15 solution templates out there, and we marked them with a special logo that you know that these all templates belong together. And I just want to download one of these. I think I will, and this is a very beginning point for creating CityGML, creating building LOD1. I can download from here, but I did it prior the presentation. And as you could already see from the screenshot that Lutz showed you, this is how these workspaces look like. First, I want to highlight again that we try to describe the workspace, we try to describe the workflow, and we also try to describe what is necessary to fulfill this workspace with your own data. So this is what we figured out, that often people do not know how their source data have to look like. And then as we already said, it's straightforward, so we can read the source data. Then we try to document some special things about CityGML. For example, if you set an attribute like function, we link to a point where it's explained what this function attribute is all about. Then we do some work on preparing geometry, and this is very special to CityGML, and maybe this is the key point of these workspace templates. We try to explain that it's necessary to set certain attributes on the geometry to make the CityGML writer know what kind of geometry he has to write out, right? So this is all around this geometry property setter, where we have to make sure that the right geometry type is set, like here, for example, a level of detail 1 solid. I think if we have time, I will choose or will show another template which is more complex. Lutz already told you that we also have workflows that reads data from the 3D city database, and this is one of these templates where you can export data from the city database into various different formats, and it's all preset so that you can just fill in the published parameters and then create the output formats. So, and with that, I think I can switch back to the presentation, and Who's doing the Outlook, Lutz? Is it you? Is it two of us? So the idea really was to, as Lutz already said, to give our experiences a way that more users can easily create CityGML or read data from CityGML. And yeah, we hope that this is maybe only the first step in having something like a community-driven development on these workflows. And we expect to have other topics around CityGML or around 3D that we can imagine that we want to publish in the future. And what do you want to do?
Well, one thing is also, since I said we have a 3D spatial data infrastructure which handles CityGML, we would like to get better data from our customers. Would make our life so much easier. So it's also one reason to bring this back to the community and really get the people to use it correctly. And we hope that we get feedback from FME users. We also have ideas about publishing more workspaces on data validation and maybe also Inspire, but that's a little bit complicated also because there's Inspire solution templates. Well, of course, in the end, we also want to show that we as companies are very good at handling CityGML data and that we can also provide additional services on top of that. So that's basically it.
Okay. And then we can just say thank you. And are there any questions?
I'm just wondering if you're working with the Land Infra group that's formation of Building Smart International and OGC on the new Infra GML standard.
So we are actually not engaging in that group. We are actually not engaging in that group, but we are aware of what we're doing and watching that. So that's currently the status. Yeah.
This morning we had a number of talks by architecture and engineering firms using this 3D model for design. How does this help in the design?
Well, basically, I think CityGML is like a basic geodata that is provided in Europe by many municipalities or local governments, or also in Singapore. They do it for the whole state of Singapore with very high level of detail in Singapore, actually. And then you have your basic reference model. And now if you want to do your design, you can integrate it into this virtual representation of the reality and do your analysis on top of that. I think that's the idea, that you have one reference model that you can use and then combine that with CAD design models.
When a CityGML model is created of a city, who owns that model? Who owns the process and the data?
Depends on who pays, right? In Germany, mostly the municipalities order it from a company and then they own it. And since we have more and more cities and federal states that go open data, then they make it public actually for everybody. But also there's, I think mainly it's state-owned. Yeah. Yeah, state, city-owned.
This is probably a beginner question, but like you said, Singapore and Europe is using this. What's North America using as an alternative?
Well, we don't have so many customers on the American market, none. But I think here it is pretty much common to use ESRI multipatch to represent 3D models, to use maybe City Engine or Autodesk InfraWorks procedural created models. That's what I know of. I don't know if there's any comparable semantic enriched 3D standard for the US. I don't think so, actually, currently. Do you know something
no.
more?
No.
Can you contrast, like, why this?
So, I don't know. You know, City,
Google's fault, really.
yeah, you know, CityGML was mainly developed in Germany and other countries around, and so maybe this is just a question of, yeah, where it comes from. I know that CityGML is known at universities in North America, but I don't know many cities or municipalities who are really using it.
I think there's one Canadian city which is using it. Maybe somebody knows? No? I think there is.
What we've heard is that in the European countries, there's much more regulation and concern about the impacts of sound and sight and so on, whereas in Canada and certainly the United States, it's more of the Wild West. And so there isn't the same attention paid to these things. So you look at Singapore, very, very compact place, high density. The less the density, the less the demand is, I think,
Yeah.
for this type of care. And so that's why the European countries seem to be leading the charge, is why
Yeah.
we think it's safe.
Yeah.
What you're saying now, we look around at standards in North America and Europe and couldn't find a lot of GML equivalent or uses in North America. So, yeah, we don't see a lot of that here.
Also, Singapore is a very good example because they really, what they tell us, well, we are a very small country with very limited space, and we have to build up very high, and we have to build up deep down into the earth. And so 2D maps don't help us at all. We need a very sophisticated 3D model of our country.
So here in Vancouver, we use 3D for our view cones in Vancouver for land approval and developing towers here downtown. So what we value, we're modeling in 3D, which is the views.
Yeah.
But more and more, we're getting 3D building models, but they're really not GML equivalents to what you have in Europe.
And I would say that from what I've seen and being at conferences over the years, in terms of Canadian cities or almost even North American cities, Vancouver traditionally is the leader in this. And I think you're right, Bill. It is the value of the view. Like if you go to almost any other place, it isn't quite so important. Because, and also we're so compressed here. We also have a very tight, dense situation. So that's why Denver, you don't see anybody caring about the 3D model of Denver. San Jose, everything is just 3 stories high. So who cares?
So what will probably happen is that in North America, as we densify and try to become more green, more efficient in energy use, some cities in North America will start to move, I think, towards the GML. What you're doing is eventually going to be adopted here.
Okay. That's good to know.
Does CityGML have the underground infrastructure?
I think there's an application domain extension for that. There's something called subsurface ADEs, right?
It's called utility ADE.
For subsurface? Or
Yeah.
Okay.
Well, the utility ADE has all the technical stuff, subsurface, like pipes, cables, and all that. But there's also some for soil and rocks, geology features, but I don't know how that's called.
You mentioned tunnels before, and I was just kind of curious, how does it deal with the slicing into the terrain to actually do the tunnel, or do they just leave the DEM surface on top? And you kind of dive through it?
I would say there are mainly two concepts to handle this. The first is there's something called the terrain intersection curve, which is exactly the place where the tunnel goes underground. Can I say that? And the other thing is to model the opening of tunnels. You have something called a closure surface. This is a virtual wall, let's say, so that you still have, for example, the chance to calculate the volume of your object, but visually it's open, right?
And that's all part of the file format?
Yeah, it's both part of the format, yeah.
Anything else? Okay, looks like it's break time then until 3 o'clock. Just want to say thank you very much. Interesting. Thank you.